Lesson 1.2 is an overview of how to solve a variety of linear equations. In our previous lesson, we looked at simplifying, but we are now ready to solve for the value of a given variable. We have a couple of tools already in our equation solving toolkit, and we know that in order to solve equations, we always need to apply opposite operations. We will look to eliminate any questions that have fractions by using multiplication and potentially looking for a common denominator. We know that we can remove any sets of brackets that we see in an equation by using the distributive property. And of course, no equation can be solved without simplifying or collecting any like terms. Although our lesson handout is set up with solving equations graphically, and we do have a chart kind of set up here with a column for a graphical explanation, we're actually going to skip over that, and we're just going to focus on solving the equations that are given to us. So anywhere you see a graphical explanation on your handout, you're just going to disregard that. So in our first question, we've got two equations given to us and we need to solve. So we have one equation as y equals negative 3x plus 2, and our second equation is simply just y equals 4. So the reason why they have given this to us is because if we were just to focus on this first equation, y equals negative 3x plus 2, you actually have two different variables. You have two unknowns. You have an x and you have a y. And remember that when you are solving any given equations, you can only solve for one variable at a time. So if we were to just look at one equation like this, we'd be unable to solve it because we don't know what x is, but we also don't know what y is. And so that's where this second piece of information comes into play. They're telling us that y is equal to 4. So that means that in my first equation, wherever I see the letter y, I can actually replace it with a value of 4. So I'm going to go ahead and fill that in. So now by filling the value of 4 in the place of y, I only have one variable left, which is x. And I can go ahead and use my tools of solving equations to solve for the value of x. So the first thing we want to do is check for any like terms. And I do see that I have a positive 2 here, which I'm going to bring over to the left-hand side of the equation. And by doing that, it's going to become a minus 2. I know that 4 minus 2 is 2. And to isolate for x, I'm going to divide both sides by negative 3. So 2 divided by negative 3, that's actually going to work out to a decimal value. And we are going to always be leaving our answers as fractions. So I'm going to leave my answer as negative 2 over 3. And that's going to be equal to x. All right, now it's your turn to try a very similar question. So we have two equations again. One equation is 1 over 2x plus 4y equals 1. And we have a second equation, or a second piece of information, that y is equal to negative 2. So I'd like you to go ahead and solve this equation, pause the video, try it out for yourself, and then come back to see the full solution. So the first thing that I did was I took the value of y equals negative 2 and I substituted it, or inserted it, into the first equation. Because by knowing that y equals negative 2, that means that wherever I see the letter y in another equation, I can replace it with negative 2. So that's what I've written down here on the screen. And now I'm going to go ahead and simplify this. So I've got half x. 4 times negative 2 is negative 8, and that is all equal to 1. So now I can go ahead and collect like terms. So I'm going to bring this negative 8 over to the right-hand side, and that's going to leave me with half x equals 1 plus 8. I know that 1 plus 8 is 9. And now I can go ahead and isolate for x, and in order to do that, I need to divide both sides by half, or 1 over 2. And 9 divided by 1 over 2 is going to give me an answer of 18. So x is equal to 18. So here's another question that you should be able to solve on your own. We've got negative 3 multiplied by x plus 4 equals 2. Remember that when we see a number directly attached to a bracket, we are going to use distributive property. So I'm going to suggest that you pause the video, go ahead and solve it, and then come back and check your answer. Okay, so if I were to distribute, that would leave me with negative 3x minus 12 equals 2. I'm then going to go ahead and collect like terms. So I'm going to bring negative 12 over. That's going to leave me with negative 3x equals 2 plus 12. 2 plus 12 is 14. And then in order to isolate for x, I'm going to divide both sides by negative 3. Now 14 divided by negative 3, that's not going to divide nicely, so I'm going to leave it as a fraction. And negative 14 over 3 does not reduce any further to lowest terms, so my final answer is going to be negative 14 over 3. All right, now let's look at equations that have fractions. So we've got 3 multiplied by x minus 1 over 2, which is equal to 7. So the first thing you might want to try to do is get rid of the bracket, because you may recognize right away that this is an example of the distributive property. But if you were to do that, that would make the numerator, or the top portion of your fraction, way more complicated. And we don't want to make this any more complicated than it is. So I'm going to suggest to hold off on the distributing until you first get rid of the fraction. And so let's take a look at reviewing how to get rid of the fraction. So the first thing we want to do is look at what number is in the denominator. Now we only have one fraction on the left-hand side of our equation, and it happens to have a 2 in the denominator. So what that tells me is that I need to multiply both sides of my equation by 2. 2 is a number that shows up in the denominator. So placement for a question like this is a little tricky sometimes. So remember that when you're multiplying by 2, you want to put it right in the front of your equation. And on the right-hand side, there's only a 7, so I'm just going to put in a 2 there. So the right-hand side is actually super simple because it's just 7 multiplied by 2, which is 14. The left-hand side looks a little overwhelming because there is a lot going on, but the way that you're going to approach this is, remember that anything encased in a bracket, you are going to just ignore it for the time being. So just temporarily pretend like this x minus 1 is not there. So if that was the case, then the only thing that would be left on the top is 2 multiplied by 3. And 2 multiplied by 3 is 6. So just to show you, I'm going to write it out. So 2 times 3 is 6. Remember, we are ignoring the x minus 1, so I'm just going to recopy it. And then we still have this over 2. Now, we can continue simplifying this because, again, if we ignore this x minus 1 portion, this would really actually then read as 6 over 2. Or you could read it as 6 divided by 2. And 6 divided by 2 is 3. We still have the x minus 1, and we still have the 14. Now this looks like an equation that you actually should be comfortable solving. And now is when you can go ahead and use that distributive property in order to simplify the equation further. So 3 times x is 3x. 3 times negative 1 is negative 3. Still equal to 14. So now I'm going to go ahead and collect like terms. So I'm going to bring this negative 3 over. And that's going to turn it into 3x equals 14 plus 3. I know that 14 plus 3 is 17. And now I'm going to go ahead and isolate for x by dividing both sides by 3. 17 divided by 3 is going to give me a decimal, so I have to leave my answer as an improper fraction. And so my answer for x is 17 over 3. That doesn't reduce any further, so we're going to leave it as is. All right, what if we had multiple fractions or more than one fraction in our equation? So this time we've got 3 minus x over 2, which is equal to 5 minus m over 3. That is actually a typo. It should be an x. So I'm going to go ahead and just fill that in here. So make your m an x. Okay, remember you can only solve for one variable at a time and they have to be the same variable. So we can't have two different letters. So that's a typo. So just fix that before you start to solve. Okay, so the first thing we need to do is get rid of the fraction. We don't want to work with fractions. We want to make it as simple as possible for ourselves. So the first thing then is to look at the numbers that are in your denominator. So this time you actually have two different numbers that appear in the denominators of your fractions. So we've got a 2 and a 3. Because we've got different numbers, we do need to find a common denominator. So something that is a common denominator for 2 and 3. That is actually going to be 6. So because our common denominator is 6, that means that every single term in the equation needs to be multiplied by 6. So it's not just the terms that have the fraction. Okay, every single term, every single number has to be multiplied by 6. So let's go ahead and do that multiplication. So 6 times 3 is 18. We have a minus sign. And then I have 6 times x, which is 6x over 2. We have an equal sign. We have 5 times 6, which is 30. A minus sign. And then again, 6 times x, which is 6x over 3. So just to give you a heads up, I'm showing every single little step, and that's just to help out those of you who need a bit of a refresher for solving equations. But if you are super comfortable with this, you can feel free to skip a few steps and just jump from the first line down right to the most simplified form. So if you want to skip this second line here, you totally can. But for those of you who just need to see every single step just to kind of get you going, I'm going to do that for you with this example. Okay, so I want to continue simplifying. So I'm going to recopy 18. Now, when I get to the 6x over 2, remember that you can actually look at this as a division. So this is 6 divided by 2. And I know that 6 divided by 2 is 3. We still have the x, so it's actually a 3x. We have an equal sign, we have a 30, and then again, you could actually read this as 6 divided by 3, which is going to be a 2x. All right, so now we have a regular normal looking equation. We do have multiple like terms, so we are going to have to collect like terms. Up to you which side you want to bring the variable to. I'm going to go ahead and bring my variable terms to the left-hand side and my plain numbers to the right-hand side. So that means that this negative 2x needs to come over to the left, and this 18 needs to go over to the right. So if I collect like terms, that's going to leave me with negative 3x plus 2x, which is equal to 30 minus 18. Negative 3x plus 2x is negative x, or negative 1x. And on the right-hand side, 30 minus 18 is 12. So be careful. Don't forget that this is not a final answer because you don't want your answer to be negative x. You want it to just be x, the variable, the letter. So in order to get rid of the negative sign, we are going to have to divide both sides by negative 1. Remember, just because you don't see it doesn't mean it's not there. There is actually a 1 here. Okay, so missed a negative sign there. Okay, so 12 divided by negative 1 is going to be negative 12. So my final answer is negative 12. All right, in our last and final example, it is another variation of a type of question that you could see with fractions built in. And this time we've got 3x minus 1 over 2, which is equal to 2x plus 1 over 4. So again, we've got two fractions, and each fraction has a different number in your denominator. So because we've got different values here, we do need to find a common denominator. So between 2 and 4, our common denominator is going to be 4. So same like before, anytime you kind of see something that looks kind of super complicated in the numerator or the top of your fraction, my suggestion to you is to put brackets around it. So I'm going to put brackets around each binomial that shows up in the top of my fractions. Okay, my common denominator we said was 4. So remember, you need to multiply both of these two terms by 4. So again, we are ignoring this portion that is inside the bracket. So this is actually just going to read as 4 divided by 2. And 4 divided by 2 is 2. And then I'm going to recopy the portion that's inside the bracket. Have an equal sign. Same thing on the right hand side, we're going to temporarily ignore this portion inside the bracket. So this is going to read as 4 divided by 4. 4 divided by 4 is 1. We don't have to write that 1. So I'm just simply going to recopy the bracket. So that's 2x plus 1. If you want to put brackets around it, you can. But because we do have a 1 in the front, it's not really necessary for you to put these brackets in. So I'm just going to erase them. Okay, on the left-hand side, we do have something that can be simplified using the distributive property. So let's go ahead and do that. So we've got 2 times 3x, which is 6x. And then we have 2 times negative 1, which is negative 2. We're going to recopy the right-hand side. And now we go ahead and collect like terms. So I'm going to bring this 2x over, and I'm going to bring this negative 2 over to the right-hand side. So that's going to leave me with 6x minus 2x, which is equal to 1 plus 2. 6x minus 2x, that's a 4x. 1 plus 2 is 3. And then our final step to isolate for x is to divide both sides by 4. 3 divided by 4, that's going to give me a decimal. Remember, we want to leave our final answers as fractions. So my final answer is going to be 3 over 4.